So in question number 4 of this third exercise, we have taken the first part of this question first, where we'll have to observe that how are prisms and cylinders alike. Now let us first list down the properties of prism to understand this question. So as we see in the first property, the base and the top faces of the prism should be congruent polygons. Also the lateral faces have to be parallelograms. Now let us observe a few prisms as we see in this set of figure. If we consider this part to be the top of this solid and this to be the base of the solid, we observe that these two are congruent polygons, basically triangular in shape. Also the lateral faces here are parallelograms. Hence we can state that this triangular prism, as both the top and the base faces are triangular in shape, is a polyhedron, is a prism. Also we see that this is a cuboid, where if we consider this to be the top part and this to be the base of this cuboid, we'll see that this again represents a prism, because the top and the base, they are congruent, and the lateral faces represents the parallelogram, the set of parallelograms in case of this cuboid. Now let us move on and see what happens in case of a cylinder. So as we see this cylinder, and if we state that this is the top of the cylinder and this is the base of the cylinder, we again observe the same property what we have in case of a prism, that the top and the base represents congruent shapes. In this case it's a circle. Also if we observe the lateral part, we see that it represents a parallelogram if we view the cylinder from its side. So this is the similarity between a cylinder and a prism. Now let us move on to the next part of this question. Now in the second part of this question, question number 4, we'll have to observe that how are pyramids and cones alike. Now to understand this again, let us again list out the properties of a pyramid first. So as we can see through these properties, that a pyramid is a polyhedron whose base is a polygon. Also the lateral faces of a pyramid are triangles with a common vertex. Let us take a few examples of pyramids to understand these properties. So here we have taken two examples where this part represents the base of this pyramid, and we see that the base is a square, where we see that this is a square faced pyramid. Now these both shapes are square faced pyramid, and also we see that the lateral faces are triangles, where the triangles go and meet at a common vertex, where this is the common vertex as we see in this figure. Now this is how we observe the properties of a pyramid. Now let's see what happens in case of a cone. As we observe this cone in this figure and we observe the base, so we see that the base is a shape which is circular. Also if we observe this cone from its side, we'll see that we'll observe a triangle, where the triangle is going to meet at this point, which we can consider as the vertex or the common vertex, because if we change our viewpoint and if we view this cone from different angles, we'll observe that we are getting different triangles, and all the triangles are going and meeting at this point, this common vertex. Hence we can say that this cone resembles a pyramid. So these are the two different parts which we have taken, where we have understood how a cylinder is similar to a prism and a cone is similar to a pyramid. And this is how we are going to answer the fourth question of this third exercise.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.